Now the second question is integral 0 to 1 sine of 3 tan inverse of x into tan inverse of x by 1 plus x square into dx. So this one I want to do as a Bernoulli's formula. So in this Bernoulli's formula I told you already, integral u dv is equal to uv minus u dash v1 plus u double dash v2 minus u triple dash v3. It will goes on up to infinity. So this u should be taken as with the I late formula. So I want to give the priority to choose u in terms of inverse function, logarithmic function, algebraic function and trigonometric function and exponential function. So after choosing u, you need to take the remaining function as dv. So whatever function you are taking as u, that should be differentiated. Whatever function you are taking as dv, that should be integrated. So we have to stop this formula till we get the differentiation value will become constant. So these things and all I told already in my previous question. So again I am just recollecting. So now just look at this question. This is not in the format of u dv. So I want to take this tan inverse of x is equal to t. So now if I take t is equal to tan inverse of x, here dt will be equal to tan inverse, differentiation of tan inverse of x is equal to 1 by 1 plus x square into dx. So this dx by 1 plus x square, I can take it as dt. So if I take this is t, this dx by 1 plus x square will be taken as dt. So this first equation can be rewritten as integral 0 to 1 sine of 3 tan inverse of x dx by 1 plus x square. So I want to change this tan inverse of x as t, here also t. This dx by 1 plus x square also dt. But we want to change the limit of this function. This is a limit given for x. I want to convert this limit as in terms of t. So whenever x is equal to 0, then I want to find the limit for t. So t is equal to tan inverse of 0, that is 0. T is equal to 0. So then t is equal to tan inverse of 1. The upper limit is 1. So that I am substituting x is equal to 1. So t is equal to tan inverse of 1. So tan inverse of 1 means which angle will give you as tan inverse 1 as answer. So pi by 4, 45 degree. So the limit will be changed as 0 to pi by 4 t. This will be taken as t. This is sine 3t into dt. So now I told you already, this is a integration by parts. I want to use a Bernoulli's formula. So first in I late, inverse function, logarithmic function, algebraic function, then only trigonometric function. So first algebraic function must be taken as u, and this sine 3t dt should be taken as dv. So u is equal to t. So what is u dash? Is equal to 1. So in first derivative itself I am getting the constant, so that I can stop the formula till v1. Here my u1 is a constant. Therefore I want to stop the integration with v1. So dv is equal to sine 3t dt. So from this dv, how you can find v? So you want to integrate sine 3t dt. So the integration of sine 3t dt is nothing but minus cos 3t by 3. So v1 is nothing but integration of this answer. Integration of minus cos 3t by 3 into dt. So this minus 1 by 3 I can take outside. The integration of cos 3t is sine 3t by 3. Therefore v1 is equal to minus sine 3t by 9. So here integration of u dv is equal to uv minus u dash v1. Because u double dash will be 0. So 0 into V2 is whatever answer you are getting for V2, that will become 0 while multiplying with U double dash. So that I am stopping this formula till the second term. So integral 0 to pi by 4 t sin 3t dt is equal to uv minus, u answer is t, v answer is minus cos 3t by 3 minus u dash answer is 1, so I am not writing. V1 is sin 3t by 9. So integral, we are substituting the limit 0 to pi by 4. So first upper limit I want to substitute. So upper limit I want to substitute here. So pi by 4. So here t into minus cos 3t by 3 minus of minus plus sin 3t by 9. So first I am writing the positive number and next I am writing the negative number for our convenient. Otherwise if you know how to do the thing, you can do it directly. So first I am writing the positive term here, then sin 3t. So I am taking 9 as LCM. So sin 3t plus, so 3t cos 3t, 0 to pi by 4. Now only I am going to substitute the limit. So this 1 by 9 I am taking outside. Sin 3, instead of t I want to substitute pi by 4. So 3 pi by 4 minus 3 into pi by 4 cos pi by 4. 0 I want to substitute, sin 0 0. Then instead of t only I am going to substitute 0. So 0 and anything is 0. So the lower limit if you substitute, everything will be 0. So we can just leave it. 1 by 9 into sin 3 by 4 is 1 by root 2 minus 3 pi by 4 cos pi by 4 is minus 1 by root 2. So this is 1 by root 2 minus into minus plus 1 by root 2, 3 pi by 4 root 2. So I can take root 2 as LCM. LCM I am outside. So I am giving this 9 inside because of the book answer. Just we are bringing this term 9 inside. So 9 I am going to take inside. This is 1 by 9 plus, because this 9 and 3 can be cancelled. For that only we are taking this 9 inside. So 3 pi by 4 into 9. So 3 times this can be cancelled. 1 by root 2, 1 by 9 plus pi by 4 3s are 12. So this will be the answer for this Bernoulli's using the Bernoulli's formula.